In this quick video, we're going to be reviewing completing the square. Remember, completing the square is a method that you can use to take a quadratic that is not factorable and make it factorable, or it's used to take a quadratic or some other type of equation that has quadratics in it and write them in vertex form or some other similar form. So remember, quadratics are equations that have a degree of 2. And here in this example, I've got k squared minus 12x plus 23. Now, before you ever start completing the square, the first thing you always want to make sure is true in your equation is that your a value is equal to 1. And remember, a comes from the first number in front of the x squared. So here our a value is 1, which means we're good to go. And then you always want to have your c value on the other side. Your c value is your constant. So I'm going to put this as step 1. So move c to the other side. So to do that, I'm going to subtract 23 over. And it's going to leave me with k squared minus 12k. And then I'm going to leave myself a blank and then equals negative 23. From here is where we actually do the completing the square step. Completing the square means we're going to take our b value, divide it by 2, and then square it. Okay, so in this equation, my b value is negative 12. So I'm going to take that negative 12 and divide it by 2, which gets me negative 6, and then I'm going to square that answer. What I get there is going to go back in that space I provided, as well as at the end, and I'll explain that here in a second. So what I get is k squared minus 12k plus 36 equals negative 23. Now, once you've done that, the left side of the equation should be factorable. That's the whole goal of completing the square, so that you can factor it. Now, the one unique thing that a lot of people tend to forget is when you're completing the square, you have to always balance the equation. So that means if you've done it to one side, you have to do it to the other. So I added 36 to the other side. That means I'm going to also have to add something over to the right side. So what I do is I take the front number, so that's a 1, times 36, and I add that number to the other side. And the reason I'm showing you that I'm multiplying by 1 is because sometimes you're going to have a number out in front. So you might take 36 times whatever number is that is out in front. Here it's just a 1, so it doesn't make a big difference, but in other problems, it will be a different number. So now we are going to have k squared minus 12k plus 36, and then I can go ahead and subtract 23 from 36, and I get positive 13. Now the goal should be able to factor this equation. So on the left side, I could factor it. K minus 6 times k minus 6 equals 13, and then I could rewrite this as k minus 6 squared equals 13. Now, depending on what your problem is asking you to do, if you were asked to solve, you'd go ahead and start solving for k by square rooting both sides and then adding 6 over. If it wanted you to write this equation in vertex form, then all you do is move the 13 back to the other side. And if you're dealing with conics, which is later in the semester, we will use this to help us write our conic equations in standard form, and so you would just leave this as is. Okay, so completing the square comes in handy with lots of different equations as long as it's got a quadratic component to it. Now in this example, notice that our items are kind of in the wrong places. Also notice that our a value is not 1, so we're going to have to address that before we start following our steps. So what I'm going to do first is get everything onto the one side except for my c value. Remember, my c value is always on its own. So I'm going to add 12x to the other side. So to get 6x squared plus 12x, and then I'm going to move that 48 to the other side. Then what I'm going to go ahead and do is get rid of this 6 here because we cannot have an a value that's not 1. So I'm going to take a 6 out, and what that leaves us with is x squared plus 2x, and then equals 48. And then I'm going to go ahead and follow my steps for completing the square. So notice that if I'm going to complete the square, that number in front of the squared term has to be a 1. And if it's not, I'm going to have to factor it out. That's very, very important. You have to do that in order for this to be accurate. Now we can go ahead and complete the square. Remember, that's to take the b value divided by 2. So 2 divided by 2 is 1. Then if I square that, I get 1, which is going to go back up in this spot. And then remember, we said once we got that part squared, we're going to multiply that number we added times the number in front. So 6 plus 1 is 6. So I'm going to add 6 to the other side. So I got my C value on its own. I completed the square by dividing by 2 and then squaring the number. And then I balanced my equation. So now what I have is 6 times x squared plus 2x plus 1 equals 54. And now I should be able to factor. The stuff in parentheses would be x plus 1 times x plus 1. And I could rewrite that as 6 times x plus 1 all squared equals 54. And then again, whatever the problem's asking you for, either it's to solve or to write into vertex form, what you do from here just depends on what the problem is asking. But in general, when you complete the square, notice that every time my factors should be identical because we want them to be perfect squares. Okay, so if they are different, that means that something's gone wrong. Okay, the goal should be that always whatever's in parentheses should always be identical, just like in the first example. So if you have any more questions about the process of completing the square, please let me know. But hopefully that helps refresh your memory or guide you through the practice problems that you're on currently. Thanks for listening.